Today we are going to see what is meant by Hdlc and PPP. So before going to the PPP, we have to know what is meant by Hdlc and PPP. So Hdlc means it is a most important data link layer control, and it also the basis for many other important data link control protocol, which is useful to the same or similar formats and the data mechanisms as employed in Hdlc. So here we are going to connect TCP/IP as well as we are going to connect the internet provider officer. So in this, it is called as a high level functionality. And then we are going for a point to point protocol. We are the combination of point to point protocol and HDLC is called as a data link layer protocol. So now we are going to see the point to point protocol. So point to point protocol is the most commonly used protocol for a point to point transfer of data. The services provided by the point to point protocol is first thing is formatting of frames to transfer, and second one is negotiation between devices to establish the link, and encapsulation of data in frame link and authentication of devices. It can be operate between point-to-point transmission link in a full duplex mode, and is it also a point-to-point protocol can be used as a data link control to connect two routers. So we are going to see the frame format for a point-to-point protocol. So in point-to-point protocol frame format, we are having a flag, address, control, protocol, data or padding, FCS, and then flag we are having here. So in flag field, we are going to include it identifies the boundaries of point-to-point frame. That is, each frame begins and ends with the flag field. This field is always 1 byte in the length. And we are going for address field. Address field indicates the address of destination. Address field is 1 byte, that is 8 bits. When the address field contains all ones, that is double one double one double one double one, this indicates that all stations are accept to the frames, that is broadcast messages only. So in control field, point to point protocol normally runs in connectionless mode. Therefore control field is set to 11100000. This indicates unnumbered frames, that is frame does not contain sequence numbers and there is no flow or error control. And next one, we are going for a protocol field. It defines the information of data field. The protocol field is always 1 to 2 bytes long, and then data field is contains the actual data to transmit. The length of this field is variable, and then FCS is also called as a by 24 byte long and contains ERC code. It checks length of all fields in the frame. We are going for a extra stuff. We are going for connectionless, leavingless, and the network layer address negotiation, and then authentication and management features. So in this, we are going to see a transition states also. So in transition, we are having a idle state, establish link, and then terminate link, and then authentication and exchange of data. So in point-to-point protocol, the transition state is used to indicate the phases through which point-to-point connection phases. So the point-to-point connection phases through 5 important states. One is ideal state, second is link establishment state, third one is authentication state, and fourth one is exchange state, and then fifth one is terminate link state. So in ideal state, the link is not in use. So the carrier is not activate in this step. And then link establishment state, when carrier is detected, one of the end points start the transmission, then connection enters into the link establishing state. Under this state, there is a negotiation between the devices. On successful negotiation, the connection enters into authenticate state, otherwise it enters into ideal state. And then we are going for authentication state. We are using a byte stuffing concept. Already we have already know the byte stuffing concept, so it will be implemented in a point to point protocol. So here we are going to see the authentication state. So here this is the authentication state we are going to see here. The authentication state is mutually decided by the station. The station sent several authentication packets. On successful authentication, the connection enters into exchange of data state, otherwise to the terminate link state. And the next one we are going for a exchange of data state. This state is also referred as a networking state. In this state, exchange of data started. The connection is terminated only after the any of the endpoints wants to terminate. So, and at last we are going for a terminating state. After exchange data is over, several packets are exchanged between endpoints for closing the link. We are going for a point to protocol stack. We are using a one frame format, so that includes stack protocol packet. So point-to-point protocol uses a stack of other protocol for establishing link and two authentications. We are going to use two major protocols. First one is a link control protocol, which considered as LCP, and second one is a network control protocol, which consider this as a network control protocol. So during connection of point-to-point protocol, carry any of this protocol in this data field as shown in a point-to-point stack. It will have a flag, address, control, protocol, an FCS, and a flag. So we are going for FCP, LCP. It performs a function of establishing, maintaining, and configuring and termination of links. LCP also involves in negotiation mechanism between stations. So and then we are going for a NCP. So when it enters in exchange of data state, NCP is a set of protocol which allows encapsulation of data from a network layer into a point-to-point protocol. Next one we are going to see a Hdlc concept. So Hdlc, another name is called as a SDLC, that is synchronous high level data link control. So in HDLC, protocol is an international standard that has been defined by ISO for use on both point-to-point and multi-point data links. So it supports full duplex, transparent mode operation and is now extensively used in both multi-point and computer networks. And then HDLC is now widely accepted. A number of large manufacturers and other standards bodies still use their own acronyms. So see, this includes IBM SDLC, Synchronous Data Link Control, and ADCCP, Advanced Data Communication Control Procedure, which is used by American National Standard Institute. So to satisfy a variety of application, HDLC defines three types of station. So what are the stations are available means, so we are going for a primary station and then secondary station and a combined station. So in primary station, it has a responsibility for controlling the operation of the link. Frames issued by the primary are called as command. And then we are going for a secondary station. It operates under the control of the primary station. Frames issued by a secondary are called responses. The primary maintains separate logical links with each secondary station of the line. And then we are going for a combined station. It combines the features of primary and secondary. A combined station may issue both commands and responses. So in HDLC, it has been issues both commands as well as responses. So it defined as a general purpose data link layer control protocol. The stations can be configured in different network configuration also. First thing is point to point with single primary and secondary. And second one is multi-point with single primary and multiple secondaries. And third one is point to point with two primaries and two secondaries. So here in point to point we are having one primary station and one secondary station. It will send the commands and it will receive by the response by the station, secondary station. And then we are going for a multi-point with single primary and multiple secondaries. It will send the commands by using second for primary station, and we are having a two secondary station that will be using as a response. And then next one we are going for a NRM. NRM is normal response mode. So in normal response mode we are going to see, so this is a diagram for HDLC primary station, multiple station and point to point station. So we are going for a normal response mode. There is a three types of modes of data transfer operation are used in HDLC. So first thing is NRM, normal response mode. So this is used in unbalanced configuration. There are one primary station and multiple secondary station is available in a NRM. And then a primary station can send the commands. A secondary station can only give the response only. So and then it shows normal response mode NRM. And the NRM is used for both point to point and multi-point links. Second one, we are going for asynchronous response mode, ARM. In ARM, the configuration is balanced. The link is point to point, and each station can function as primary and a secondary. Either station can send data, control information, or commands. So this is typical in connection between two computers and in the X.25 interface standard also. And then we are going for frames in HDLC. We are having three types of frame. One is unnumbered frame and an information frame, and then third one is a supervisory frame. So we are going to see the information supervisory frame and unnumbered frame. Means in unnumbered frame we are having the functions such as link, setup and connection. The name derives from the fact that they do not contain any acknowledgement information which is contained in sequence number. And then we are going for an information frame. These carry the actual information or data and are normally referred to simply as iframe. Iframe can be used to piggyback acknowledgement information relating to the flow of iframes in the reverse direction when the link is being operated in ABM or ARM. So we are going for a supervisory frame. These are used for error and flow control and hence contain send and receive sequence number. So we are going for a frame structure. In first thing we are having the flag. The flag address and control bits before the information or data fields are known as a header. The FCS and flag fields following the following data fields are referred as the trailer also. In flag field, it has a unique pattern at both the end of the frame structure. It identifies the start of the frame and end of the frame. So the length of flag field is 8-bit. Address field, we are going to see the destination address, and then address field is usually 8-bit long but can be extended. In control field, it contains frame numbers. Also, it controls the acknowledgement of frames. Control field is a 8 or 16 bits in length, and then information field of this contains user data received from the network layer. It can be variable length but in integral number of octets. And then we are going for a frame check sequence. It is a error detecting code calculated from the remaining bits of the frame. FCS can be 16 bits or 32 bits long. In control frame, in control field format, we are having a iframe or designed to carry user data from the network layer. This field also includes flow and error control mechanism. And then first it defines the type. If it is 0, this means the frame is an iframe. The next 3 bits defines the sequence number. The sequence number ranges in between 0 to 7. P and F field is 1 bit with dual purpose. This field is set when it is in 1. It may be pole or final. So last three bit corresponds to the acknowledgement number when piggy banking is used. And then we are going for a control field of S frame. We are using a 0, 1, sorry 1, 0 and P by F. So in this, if the first two bits of the control field is 10, this means the frame is an S frame. The last three bits called N of R correspond to the acknowledgement number or negative acknowledgement number NA key depending on the type of S frame. So the two bits called node is used to define the type of S frame itself. So in S frame we are having a receive ready and then receive not ready and reject and then selective reject we are having here. Then we are going for a control field U frame. It contains an information field and but one used for system management information and not is for user data. So in address field, we are going to use a 16-bit CRC generating the polynomial code, that is x power of 16 plus x power of 12 plus x power of 5 plus 1. It will be expanded by using a polynomial expansion. So in this HDLC, we are using only three different classes only. I already told you that unnumbered frame, information frame, and supervisory frame. So in unnumbered frame, it will be called as a U frame, and information is called as a I frame, and supervisory frame is called as a S frame. So here we are going to give a supervisory different types of four supervisory here. First one is SS is equal to 0 0, the receiver is in ready state, and SS is equal to 1 0, the receiver is not in a ready state, and SS is equal to 0 1, the receiver is in a reject state, and then SS is equal to 11, the selective reject state will be enabled. So and then we are going to see the unnumbered frames can be grouped by the following categories. One is mode setting commands and responses. Second one is recovery commands and responses. Third one is miscellaneous commands and responses. So in this topic we have seen what is meant by point-to-point protocol, as well as we have seen a HDLC. So in point-to-point protocol, we have seen the what is meant by frame format, and then what are the transition states are available, and then what is meant by point-to-point stack, and then what is LCP and what is NCP we have discussed today. And then in HDLC concept, we have discussed what is meant by HDLC, and then three types of stations are there: primary station, secondary station, and combined station. And then we have seen the operations mode, NRM, and then we have seen the ABM, and then in frames we have seen a U frame, I frame, and S frame. And we are going for a control field also, we are going to see a I frame, U frame, and S frame. So in this link layer control, we are having a services. That services will be combined as framing, error control, reliability, connection management. Last class we have seen the median access control and then switching concept. So we are going for a protocol and standard. We are having a Ethernet, token ring, FDDI, wireless, PPP, and HDLC. Thank you.